Now we are going to start with the basic terminology which is involved in this chapter. That is, the first is the complex ion. This complex ion is also called as coordination entity. It can be called as this also. So what happened in this case? It is electrically charged species. It is an electrically charged species in which there is a central metal atom surrounded by many groups or the neutral molecules which are actually linked. As we discussed before also, suppose this is my coordination compound or this is my coordination compound. So this is my complex ion, or you can say this is my coordination entity in which I have the central metal atom and the groups also which are joined to it. This is called as coordination entity. Now this complex ion or the coordination entity is further divided into cationic complex or the anionic complex, just depending upon that what kind of charge it possesses, like what kind of charge is there on the complex ion. Depending upon that, we have the cationic complex, we have the anionic complex. In the cationic complex, there is a positive charge. As you can see in this case, platinum NH3 whole 4, 2 positive. So because it carries a positive charge, so that means it is a complex ion obviously, but what kind of complex ion? Cationic complex ion, because it carries a positive charge. And here the anionic complex, again the same thing, which possess the negative charge, like FeCN6 bracket, and this is 4 negative. So when there is 4 negative charge, so that means any negative, any kind of negative charge, so it indicates obviously it is a complex ion again, but what is it? It is a anionic complex. So this is what is the complex ion. So what is complex ion? It is a complex ion or the coordination entity is that in which there is a central metal atom, can be an atom or an ion, and which is linked to the other groups or the ions or the neutral molecules. So this, if it, obviously it is going to carry a charge because it is charged complex actually, and if it carries a positive charge, it is cationic one, and if it carries a negative charge, it is an anionic complex, right? So this is what is the complex ion. Now moving on to the central atom, as I told you that it includes the central atom and it includes the groups which are further joined. So this central one is called as central atom. Now the question is that whether this central atom is going to be metal, non-metal or metalloid. So it is again a metal. And what kind of metal actually? It can be transition metal, or inner transition metal. Means it can be a member of D block or it can be a member of F block. As I told you that D block members are actually very keen in forming the complex because of their small size, high charge density and weak d orbital, right. So that is why generally this central atom is transition metal or inner transition metal, and it can be an atom, it can be an ion also, and to it actually a fixed number of groups can be joined and by coordinate bond. So what is central atom? Central atom is basically a transition metal or inner transition metal, and to which the fixed number of groups or neutral molecules or ions are actually joined to it. So that is again a central atom. So in this case the central atom is Fe, in this case again it is Fe, in this case it is platinum. So likewise you can actually make out that what is a central atom in the given complex. Now moving on to the groups which are actually attached to the central atom, they are called as ligands. So ligands are actually the groups which are actually joined, fixed number of groups which are actually joined to the central atom, right. And why they are joined now? They are joined because they are electron donors. They are actually electron donors. That means they have an extra lone pair, or you can say they have the lone pair actually, so which they can donate it to the central atom. So ligands are actually electron donating species which are bound to the central atom obviously by a coordination bond, and it is obviously included in a coordination entity, that is in a complex ion. Now ligands can be charged also, they can be neutral molecules. As I told you that ligands are the groups actually, specifically ions or the neutral molecules which are actually linked to the central atom. Now how many lone pair actually they possess, or how many donor sites? We can just transform the lone pair into the donor site, because the donor site obviously means the lone pair only, because that is only they are going to donate to the atom. So the number of donor site which a ligand possess is particularly called as its denticity. And depending upon denticity we can classify ligands into many kinds, that is unidentate, bidentate, polydentate, right? And depending upon the symmetrical and asymmetrical ligands, we will be classifying into further into chelating ligands, bridging and ambident one. So this will be taking later. So now we are like for this moment we are just considering the denticity part. That means how many donor sites actually they have. 1, 2, 3, 4, 5, 6, how many? So depending upon that we have unidentate, we have bidentate, we have polydentate. Like if it is 4, you can say tetradentate, it's 5, pentadentate, 6, hexadentate. But what we do after 2, we just club all those them tridentate, tetradentate all into a polydentate type, right. So this is what is the type of ligands. Now moving on, that what are actually unidentate, bidentate, polydentate, I have few examples. Unidentate, as the name suggests, uni means one, so that means they can link to the central atom as they have one donor site, one lone pair. Example, H negative, NH3 and much more, in which like in any ion or any neutral molecule in which there is this thing, the one donor site, that means one lone pair, it suggests that it is a part of unidentate. It can actually link to a central atom as it has one donor site. And if it has 2, as the name suggests, bi, so that means 2, if it has 2 lone pairs, or if you can say it has 2 donor sites, then particularly it is bidentate. As you know that it is present in water, 2 lone pairs on oxygen. This is the oxalate ion. So likewise you can have many more. Polydentate, like after 3 we club all of them into a polydentate type. We just put those tridentate, tetradentate, pentadentate all into the category of the polydentate. So they can have this thing 3 or more donor sites in them. For example, we have EDTA, it is actually hexadentate. See, there is a lone pair on this end, so it can link to central atom by this point, can link by this point also, can link by this point also, this also, because they are negatively charged ions, and these n actually contains the lone pair. So it can actually link by as it has 6 donor sites, 1, 2, 3, 4, 5 and 6. So it is again a hexadentate and falls into a category of polydentate. So likewise, depending upon the denticity, we just divide them into unidentate, bidentate, tridentate or tetra, penta, all club into a polydentate type. So this is what is the denticity. Now we are going to classify the ligands depending upon the symmetrical ligands and the unsymmetrical ligands. So just look at the board.